Hey, everybody. Welcome back to another episode of Automation Nation inside Barnum. I'm your host, Cody. And across from me on the mic today is Ryan with Pulse. We're going to be talking about some power supplies and why Pulse is just a heavy hitter and different in power supply realm. Thank you for coming on with me, Ryan. Could you give me just a quick little rundown of what you do for Pulse? How do you work with Barnum, and how long you've been doing that?
Yeah, well, Cody, thank you so much for having me in today. I am the Michigan area sales manager for Pulse. I've been with the company 3 years now, and then about 13 years total in the automation industry, in various different roles. I work with Barnum. You guys are our channel partner into the market, so we would work together and meet with customers. They would purchase through you, and you would purchase through us. You guys stock us, promote us, promote our product. Do a really, really fine job doing that too. Thank you.
Yes. Now, Pulse is, I guess really, how long has Pulse been the big hitter for our industry? You know, have Barnum, have we been repping you guys for a long time? You know, obviously Pulse is not a new company, but like, how long have we been working with you? How long has Pulse really been around? You know.
Yeah. Barnum and Pulse got together about 2 years ago to start partnering together in Michigan and the various other areas throughout the country, and we're growing every single day with Barnum and throughout different areas.
How long has Pulse in general been around? They've been. I think you and I were talking the other day. Pulse is one of the pioneers of like the DC power supplies, right? They've
Absolutely.
been around for a long time. It's
Yeah.
not a new brand on the market.
No. Our owner and founder, Mr. Bernard Ertl, was the first one to take a switch mode power supply and put it on DIN rail, and that was back in 1980. And that's pretty impressive if you think about the control voltage that was going on for then and many years beyond 1980 was 120 volts AC. So very much so, he's been pioneering the way to get DC voltage moving on. And he realized very early that in order to get people to adopt 24 volts DC power, that he had to build the world's most technologically advanced DC power source. And that's been our mode of operandi moving forward.
Sure. So Pulse, and Pulse has obviously been in it forever. They're heavy hitters. Where's Pulse headquarters? Just out of curiosity, is it Germany?
Munich, Germany.
Germany. Yeah.
Yep. And we have manufacturing in the Czech Republic and China.
Okay.
In North America, the power supplies sold in North America are all from the Czech Republic.
Okay.
Minus like a couple SKUs that are only manufactured in China, but by and large part.
Sure.
The Czech Republic.
Now, Pulse obviously starting way back, leading the way, charging with technology and being that first ones to do that DC power, things like that. Obviously, that starts a whole trend of technology, and they are the leaders. So really, what sets Pulse apart from? Everyone's got power supplies nowadays. 24 volt power supplies in every single panel. Every darn company has a 24 volt DC power supply or whatnot. What really sets Pulse apart in our industry?
Well, I mentioned that we have manufacturing in both the Czech Republic and China. So one main thing is that we manufacture our own power supplies. So, and we also design our own power supplies, and that allows us to select the components that meet our high reliability standards. When we design them, we make sure that they meet our size standards, which are very, very high, and then the efficiency standards as well.
So Pulse being the true designer and manufacturer of them, you guys set your standards, you create what you want, have the product that you want. It's not a lot of different companies with private label or work in partnerships, things like that. And it's you get what you get. But Pulse creates it from the ground up.
Yeah.
So you guys get to set your own standards.
Yep. And one unique thing too is when we are developing new technology, we will ask customers and meet with customers and get their feedback as we're developing it and then incorporate it so that when it does come to market, it's ready. It has customer buy-in to that.
Yep. I guess, at the end of the day, a power supply is a power supply, but certain things, certain technology or innovation has to set apart, Pulse from other people. What are some of the things, big highlights, I guess, that Pulse really can pride themselves on of being either more technologically advanced, more reliable, energy efficient, that's put into one or all or certain lines from Pulse? Like, what are some of that technology that really sets it apart?
Oh, sure. So I mentioned our high standards. Those are internal standards.
Mm-hmm.
They're not like industry standards like
Yeah.
NEC Class 2. So part of the design is we'll put the transformer at the top, which is the hottest component inside the power supply. So that gets rid of the heat out of the power supply the quickest.
Sure. That makes sense.
And then we intentionally lay out the board of the components on the board
Mm-hmm.
to create some channels that run through the internal of the power supply, and that helps get heat. That helps move cool air through the power supply, increasing the lifetime of the longevity.
Okay.
Furthermore, in our Dimension series power supplies, we don't use electrolytic capacitors that go into those power supplies that are smaller than 10 millimeters or have a lifetime shorter than 50,000 hours.
Okay. So, I mean, I guess really on that, there's a lot more than just throwing components on the board and putting it in there. Every little thing has their own methodology to it. And that's, again, going back to why Pulse is the designer of these, not just an assembler.
Yeah, we're not throwing a bunch of components inside of a metal enclosure
Mm-hmm.
In a way that can take AC voltage, turn it to DC voltage, and calling it a power supply.
Sure.
There's a lot of thought and time and energy that goes into
So then with that, kind of
to
segue or not pivot from that, but to continue with that, the way heat and everything is really well managed with these, does that obviously increase the lifetime? You said about 50,000 hours. Is that pretty high? Is it higher than the average in the industry, or do these power supplies in general, are they a longer lifetime product than the average Joe's power supply on the market because of those features?
Yeah. So we publish all of our lifetime hours,
Mm-hmm.
longer than 100,000 hours on most SKUs. And I'm not shocked when I see that it's 5x longer than what some of our competitors can be. And that's taken off the data sheets of the capacitors. So again, we select the components that go in there. We're making sure we're putting high quality power components into the power supply to deliver a high quality product to the market.
Now, Pulse in general is known as a premium supplier. They are a premium power supply, high-end stuff. I can't imagine, the product that you guys represent is cheap. It's well made, it's premium. What would kind of get customers, engineers, OEMs, whoever, to really want to start using Pulse? Like, why would they want to spend the extra money? Break that down for me. Obviously you guys take a lot of care and effort and technological advancements, but power supply can be a power supply. Just whatever. Just grab a cheap one.
Yeah. There's kind of three essential resources that our customers and OEMs have. If you boil it all down, that could be time, money, and energy. And when you factor the time spent procuring the components, you want it to be able to last. If you put your brand on building a machine, you want it to be able to last. You don't want to be known.
Power supply is really the heart of a machine.
It is.
It's not going to run unless the power supply is running. So
right.
If that's constantly croaking out on you, there's a lot of time wasted. Right there.
Yeah, nobody wants to go and out to a panel to replace a power supply if they don't have to. So with a little bit more investment up front, you can remove that issue out of your system.
And then efficiency or energy, with these things, paying that little extra premium for these very, are you getting a little bit more out of it, more efficient, more energy out of them?
So the high efficiencies, that can matter a lot. End users will care about that, especially if they have green initiatives. So I did a little bit of math, and I found that our 40 amp power supply is 95.3 efficient. You divide 960 watts divided by 9.953. You see that 1,007 watts is needed to power that 960 watts on the output. If you take just 2% efficiency out of that, it takes 1,032 watts to power that same 960 watts. So that's a difference of 25 watts, right? It doesn't seem like a lot, but if you've ever touched a 25-watt incandescent light bulb, that can get pretty hot. That's heat inside your panel, and heat is the enemy of electronics. So not only the electronics of the power supply, but what else is in that panel as well? You've got a PLC. That's the brain of an automation system, right? Probably some I/O blocks that go in there as well. And then if you extrapolate that 25 watts out over the amount of power supplies that go into a plant, you're talking real energy savings.
Yeah, I guess that's probably something a lot of people don't think of either when you're looking down and dirty at a single power supply. But when you multiply that by entire manufacturing facilities, that is a lot.
A lot.
I mean, we hear that all the time, just even in our own homes. You know, they say, you know, changing that thermostat by 2 degrees could save you how much over the course of a summer, or, you know, replacing those light bulbs with LEDs. Just those little things, how big of a difference it makes. And we usually don't care as much on homeownership or consumer side as much as a large company that's running every single number, trying to save every single dollar at the end of the year. So a little bit of upfront investment actually saves them money in the long run, or time. And obviously other components, because it all factors in. It's all under the same umbrella. If you're overheating other components, or if other components have a shoddy power supply attached to them, maybe you're replacing those more often. Just
that small 2% doesn't seem like a lot, but when you extrapolate it out, that's real money.
Now,
real energy.
Just as like a kind of quick blanket overview, what are like the different categories of power supplies Pulse covers? Obviously on the table here we got some obvious different things. We'll talk about them in a little bit. But like from the biggest of the big to the lowest of the low, I don't know, is there anything unique? Like what does Pulse kind of blanket over?
So we're 100% DC power supply.
All DC
company.
Okay.
Yep. 100%. So we have a very broad product range. So no matter if you are up at 960 watts or way down at 60 or below, you can trust that you're still getting that reliability from Pulse.
Sure.
So we'll cover all of your bases as a standard product because we have such a broad product range. As families are concerned, we've got what we call a mini line, a piano line, which is an economy line, our dimension line, which has 2 separate categories in it as well. And then from there, we'll break out into electronic circuit protection, power supplies with built-in redundancy to help save space in the panel, redundancy modules, DC UPS backup systems, and then we've moved into a world to take it outside of the panel, to take the DC power source outside of the panel with our IP67 Field Mounted power supply line.
Sure. That seems like that realm on its own, taking stuff out of the panel, is becoming more and more popular every year. We're seeing that from standard I/O to VFDs. Yeah, you name it. People are trying to take it out of the panel. I mean, obviously less wiring, less stuff to get hot, easily serviceable stuff when it's out of a panel. You don't need to kill all the mains power or do some safety checks to get in there. So you guys jumping on that with a field mounted power supply is actually it's a pretty cool product.
Yeah,
it's a cool market, and it melds well with a lot, especially that Barnum does. I mean, that's what we got here. If you're not watching the podcast, we actually have one of the field mounted power supplies on the table here, and this thing, this is a DC power supply, just like something that would be on a DIN rail, but it's out here. And this thing is really, form factor is really slick. And I feel like in the realm of a power supply, this thing should just be this big hot box in my hand, because it doesn't have all the holes that you'd see on one that's inside a panel. But obviously you can't have holes all over something if we want it outside the panel.
Nope.
So obviously some good technology has to be in these things to function without overheating and all that. And it's got a bunch of buttons on the front. So this is more than just a power supply. It actually has some control with it too.
Yes.
And it says IO-Link on the front of it. So, almost all the Barnum customers know what IO-Link is now. And having a power supply that has IO-Link on it is also pretty darn unique. What was the big I guess driving factor for Pulse to make this? Do you know?
So one thing that sets us apart in the IP67 Field Mounted power supply line is that we have a 3-phase input. So you can take 480 volts and bring it straight down to our field mounted power supply. From there, it'll give you 25 amps, which is also unique to the market, and then either take all 25 amps out of a Harding connector or break out the load into up to 4 different outputs. So a good way to think about our field mounted power supplies is as if it's an enclosure, a power supply, and a electronic circuit breaker, all in one unit.
Yeah, I noticed on the front of this here it has 4 different outputs, but we only have 2 plugs on it, so obviously these must be split into two lines.
Correct.
And these are like a 7-inch mini. I think you got Harding style connectors on these, and even like I think L code. So
Correct.
you have quite different output powers, and then there's percentages on here, and then some other things with some LEDs. So it looks like you can change your output voltage and current based on one of your 4 outputs.
Yes.
Built in on this.
Yep. It's very, very simple to set up. If I can do it, I promise you anybody can do it. And if you do have the IO-Link version, you can all do it through the IO-Link Master technology, right? And that technology is provided by whatever the master block would be, right?
So you can modify the current and the voltage going out for each individual output, and then you said it's electronic circuit breaker too?
Voltage would be for the entire device.
Okay.
Each output is independently configurable.
Okay.
Yep. And you can monitor the output from the face of the field-mounted power supply as the device as a whole, up to 15 or 25 amps, or for each individual output. And then it says when you're monitoring the outputs, you're monitoring the percentage of the set point.
Okay.
Right? So if you set it to 8 amps and you're reading 30%, you're running at 2 amps.
Sure. So you can monitor the load on each output, which is that's pretty nice. And then the electronic circuit breaker that's built in on these, that's resettable over IO-Link.
Yes.
Or button push on here.
Configurable over IO-Link or in the field. And then you can also lock it out through IO-Link, so only authorized users can have the ability to reset or change a setting. And there's also a way to lock it out from the faceplate too. So again, only authorized users would have the ability to do that.
That's a slick device. I mean, honestly, it probably comes at a premium cost, but goodness, the amount of features in that thing and how many devices in one it is now.
You say it comes at a premium cost, but at what expense, right? Yes, if you're comparing a field-mounted power supply that's 25 amps, 3-phase, to the cost of a 3-phase 20-amp power supply, it's going to be more expensive. But what are the cost centers that go into developing a remote, control cabinet?
I mean, this basically replaces a whole power distribution panel within reason. I mean, everything is going on in here. You got rid of terminals that would be going between your circuit breakers and your incoming outgoing power. You got rid of, obviously, the panel itself, all the individual wiring, and other just multiple mini components. If you wanted to monitor some of that, you'd have to have current or voltage monitoring sensors in there passing through. There's other things that this thing just completely removes in one piece.
Yeah.
I mean, it's a really cool device.
It eliminates cabinet design time. It eliminates wiring time, reduces design verification, reduces time to FAT, reduces time to get out. Once you get it to the market, reduces time to set, or not to the market, to the end user for the OEM building it up, reduces time to set up the machine and commission it. So, and then they get paid faster.
I guess you can this type of thing really allows a machine to be modular too, and the fact that, let's say, customers got modular conveyor systems. You can run your 3-phase out there that's powering your motor. Then it comes to this, all your sensors, your I/O, everything is on here. That whole piece is now completely separate and in its own closed loop than from the rest of the control panel. So it's easy to build those in chunks or replace a whole one in chunks, things like that, instead of this whole new rewiring of the system or figuring out the new power system that has to come in for the whole machine in your giant 2-door cabinet.
Yep.
So
yeah, you just bring a cable out to it.
Yeah.
You land the cable, you twist it in, and then off you go.
Yeah. Disassembly and assembly, I mean, no brainer.
Yeah.
It's a cool piece.
So to come back to it, yes, it is more of an investment when comparing a field mounted power supply that's 25 amps in 3-phase to a 20 or even 40 amp power supply that's in the panel.
Yep.
However, if you think about the time and all the savings that are associated with it, it really is a cost savings at the end of the day.
And it's safe. Since you screw something in and it's internally circuit protected, there's a lot less chance someone's screwing around on the panel is going to jolt themselves.
Yeah.
I mean,
the cables and connectors are already rated for 480 input, and the M12L coded connectors are rated for 16 amps output.
Yeah. Yeah, this is cool. So if someone hasn't looked into these yet, go take a look. I assume these are all over the website. Field power supply, the FIEPOS, FIPOS.
Yes. We have 6 total models in our basic supply that give you the entire amperage out, similar to what an IP20 power supply would without routing it through an electronic circuit breaker. And then we have 2 models that are actually 25 amp single phase if you have a 240 volt AC input.
Okay.
We have 12 single phase E-fused, which allow you to change the voltage and the current. And we have 10 that are 3-phase E-fused as well, allowing you to change. And all the differences between all of those is IO link or DCOK, and then the different types of connectors that our customers or OEMs might need. So again, standard products, broad product range helps lower the time, money, and energy our customers spend even thinking about it, right? Brain power's energy too, about having to put it in.
Have you guys seen that maybe a lot of different components, even in your own portfolio, might be going this route? Like, is going to make an option for almost everything in IP67, or is it kind of its own? That's probably where the market's at right now.
So right now we're focused on filling out the line.
Yeah.
We came out with a single phase 15 amp, 240 volt, 25 amp, and then 3-phase 15 or 25 amp.
But it's not a all hands on deck. Everything we make needs to be IP67. There's really no.
We want to focus on filling out the line. So we're going to go down in wattage to like a 100 to a 100 watt. One with 2 100 watt outputs. Those are going to be NEC class 2, and then a 200 watt output.
That'd be nice just to have some more smaller ones for little modular areas of a machine that you just want to slap your power supply on. And
not all applications require more power, more connectors that are 15 amp and 25 amp power supply. Not all applications require that much, so it doesn't lower the customer's total cost of ownership. It doesn't save them money to invest in a little bit more. So we're going down in wattage for those like single station applications, and then eventually we're going to go up in wattage, which will include a safe turn-off switch that'll allow customers to drop out motor power while keeping safety and sensor power on too.
Oh, that'd be cool. That's something I always think about too. Like, we got these ones with the big outputs, but if someone says I need to just throw a little 5 amp power supply in there, that's all I'm going to use for some sensors. Okay, now I got to build a little panel, hide my power supply in there, or get some little plug and play one that has no control over it. You can't monitor it. You get nothing. But if you want some more features, I'm going to have to just put this huge one on there. So it's nice that you guys are coming up with some smaller size ones too.
Yeah. Huge in wattage, not huge in size.
Yeah. Now the other thing we got on the table, this guy, I think this here on the end is fairly similar to how this functions. that's kind of a good conversation. This is an internally circuit protected, it's a circuit breaker style power supply, right?
Yeah.
This is just the DIN rail version, so a lot of the technology that's in this is in this,
Sure.
correct?
Yeah.
So people who aren't seeing, we got a whole nother demo on the table here with a bunch of stuff on a DIN rail. We'll go over what each one of them is here, but there's one on the end that has some buttons and a bunch of different channels, and it has some outputs on it, it looks like. But overall, what is this? It says it's the PISA-B.
Mm-hmm.
So how does this one work, and what is that?
Yeah, so we have an 8-channel electronic circuit breaker in kind of 4 different flavors. You're in the decision-making tree.
Mm-hmm.
First, you need to decide if you need an NEC Class 2 device or if you'd like to have control over the devices. If you want to have control over it, channels 1 and 2 will allow you to program each individual channel up to 12 amps, 3 through 8 up to 10 amps. And you can feed a 40-amp power supply into it. So what it does is it allows you to take your 40 amps and break out that load, which is common today, but people are using traditional circuit breakers to do it, right?
Yep.
So in about a quarter of the size, so about the width of 2 traditional circuit breakers or fuse blocks, you can get up to 8 channels. Again, shrinking the size of the panel.
Yeah, that's a pretty cool device.
Yep.
I see you got inputs for resetting everything as well, an alarm on it.
Yep. The alarming can be done 2 ways.
And can you jumper a couple together here then too? Is that what these slots are?
Yep, up to 8 of them. So up to 64 total devices.
Wow.
Or 64 total outputs. Still a 40 amp input, but up to 8 of them.
Just got a lot of control going on with your power inside that panel now.
Yep. And you mentioned the alarming outputs.
Mm-hmm.
There's 2 different ways that the 8-channel can alarm. And we'll get into the 4-channel here in a minute. But the 8-channel can alarm either with a discrete output that says that channel has tripped. So you can't differentiate between channel 1 and channel 7.
Yeah.
Or you could use a digitally coded output of the electronic circuit breaker to determine which channel has tripped. And you could even image that to your HMI.
Mm-hmm.
If the PLC is networked, anybody in the world could get that notification and then send a reset signal to that.
Again, no
device.
More opening up the panel, reaching in on a live circuit, and resetting your circuit breaker.
Yep.
I mean, that's exactly what people want.
Yep. Yep. No glove up, no spacesuit. Yep. You see the sensor array attached to channel 7 requires troubleshooting. You go out, troubleshoot that because you know exactly where to go based on the manual of the machine, I would imagine. Fix it. Try to reset it. If it resets, off you go. Yeah. If it doesn't, maybe a little bit more work needs to be done. But at least you know where to go.
Instead of just, let's just throw the guy at it and see what's wrong.
Mm-hmm.
Now you know.
Exactly.
The more info, the better, and that's where everyone's going. We want to collect data. We want to know what's going on ahead of time because the more you know, the less downtime there is, the more money you're going to save because downtime is money.
Mm-hmm.
And that's every business needs to make money. So that's the conversation with a lot of these pieces. Like you said before, it might be a little bit more upfront investment, but man, in the long term, the things it can save you.
Yeah.
Now, the rest of this big board here, I mean, it's not that big, but what else is going on here? Looks like we got some more power supplies, and then we got this bigger guy in the middle here, and it kind of looks interactive. So give me a quick rundown on what we actually have here in front of us.
Yeah, so on the left, we have 2 single-phase 10-amp power supplies that have built-in redundancy.
Okay.
And they're no bigger than the power supplies we sell that don't have built-in redundancy. Because we lay out the board, we left space for the MOSFET that helps share the load between the 2 on them. So it's the same size. You're just sticking 2 together. And what this allows us to do is to eliminate a single point of failure in our DC power system. So I call this the reliability demo. So if we were to lose one power supply or the AC input to one power supply because a truly reliable or redundant system will have 2 separate AC power sources, right? So maybe the power supply doesn't fail, but the transformer upstream of it does. And then, so we would lose power. Would you mind switching one of the 2 switches right there? Doesn't matter which. So the light's gonna, as soon as the hold up time bleeds off, the light's going to go off. Now the light right here is our critical load.
Yeah, so this is actually our device power supply going out to
The
sensors
field.
within the field. This is what's actually maintaining
Yep.
the actual critical devices.
But that pilot light is simulating a critical load, like
Yeah.
a power supply that cannot go down.
Yeah.
And now
so we lost power. We saw no flicker on anything else.
Exactly.
It's held perfect the whole time.
let's lose power to the whole plant
Okay.
by switching the other device.
So both of them off. Basically, the equivalent of me just unplugging this board.
Yep. So again, the critical load did not flicker
Yeah.
in any way. And what that pilot light that just came on is simulating the DC UPS system. So even if you lose both power supplies or the AC feed coming into both redundant power supplies, you are still going to get enough time to back up your, to safely shut down,
Yep.
right? Back up your system, save whatever data you might need.
So that DC UPS, that is, says capacitor on it. So it's a capacitive storage. It is not a big lithium battery or anything like that. And so I would assume, obviously, that means you have less overall storage because it's a capacitor versus a battery, but it's probably more, I guess, economical to use a capacitor over a lithium battery? Or is it more seamless of a transition to power? What's the benefit of that?
So a battery needs to be replaced every 3 to 5 years, right? It's just what a battery does. It's a battery, right? So capacitive storage is maintenance free, essentially. Sure. So you're right, you don't get as much amperage for as long as you would with a battery, right? 200 amp hour batteries are huge, and that's as high as we can go with our battery backup systems. So you don't get the time or the amps that you would with a battery, but you do get the maintenance free option. Sure. It does cost a little bit more up front, but that's the trade-off, right? You don't have to replace batteries. You don't have to trust the maintenance team if they forget to replace the battery. You don't need to worry about not having a battery when you need the system to work in 3 to 5 years.
Obviously, in general, it matters on the load for how long something like this will last. But in general, about how long will this stay up and running, do you think? I mean, I have nothing. We have no sensors around this. I unplugged this board. How long are my green lights probably going to stay on?
5 amps for a couple of minutes. Right, and there's just not a lot of load here, so I've been on the automation trailer and completely forgot that I've turned off both loads, and have come back to it, and that pilot light closest to you is still on, so it can go a while. More than enough to get your alarms out, let people know something's wrong, come shut down machines. You know. Yeah, more than enough. And we have a chart inside of our catalog that can help you determine amperages and for how long. We also have a questionnaire available that you can fill out, submit to our applications team, and they'll make a part number recommendation to you. Okay. Or just contact your local Pulse rep or Barnum, or contact your local Pulse rep, and we'll be happy to assist. So I guess kind of as a to circle back a little bit, we've been talking about some of like the premium. I mean, everything's premium, but some of the real high end, the flagships of Pulse. You did mention earlier in passing too. You had economical series, a more entry level series. What is as Pulse being known as the premium power supply? What was the goal with that, and what is that? You know, just to kind of compete with some of the other guys that don't need all the other features, or what is that more economical line that you guys have too? Yeah, so we have what we call a piano line, which is an economy line, and it was really important, again, high standards that we have for ourselves, that we didn't sacrifice efficiency or size to develop this line. Okay. So the differences between the piano line and the dimension line is that the piano line doesn't have hazardous location ratings like Class 1 Division 2, ATEX, IECEX. Not every application requires that. Yeah. So if it doesn't, then why have a power supply that meets that, right? There's an area in the market that we could fill without sacrificing size or efficiency. Sure. And then it also doesn't have any power reserves that our Dimension series will as well. But a lot of engineers that I've worked with over the years already factor in 20% above what they're needing, so they may not need those additional power reserves. So for those two reasons, we found that there was an area in the market that we could fill that space with an economy line.
That makes sense. I mean, if you don't have a broad portfolio, you're only going to be known for one thing. So it's good that all the bases are covered. There's entry level all the way up to the best of the best. And, I mean, Pulse has got you covered when it comes to DC power.
Yeah. Yeah. And I always like getting into the applications too. For instance, if there's a 3-phase application that's running a motor, we have a power supply that's geared towards motors.
Sure.
Right? So it's got a little bit bigger of an output capacitor that can handle regen voltage a little bit better. But it's a little bit noisier on the output stage. Fine for a motor, not so much for electronics. So understanding the application, we can help save money if we find out that it's for a motor.
Sure. That's nice too. It's not just pick something from the catalog because that's the output wattage unit or whatnot. You guys have the team to also develop and pick out the right power supplies for the application,
right?
Not just a cabinet that needs 20 amps.
Let's talk about the application. Yep. And in that way, a power supply is not a power supply.
And then I guess, kind of to go with that, picking out product, things like that, is there any good resources other than, someone from Barnum or someone from Pulse that someone on their own can help look into these power supplies, figure out what they might need? Good part finder or application pages on the website, something like that?
Yeah, if you go to www.pulsepower.us, you will hit our landing page. I think the parameter search is really, really easy to use. I think it's really intuitive. If you know the part number, you can search the data sheet to come up directly, which are extensive. Some of them are 30-plus pages long.
Some of these part numbers are a little odd, not that intuitive. So I would assume that parameter search really helps if someone has no idea what part number they should be looking for.
Yeah. Yeah, if you know what your output voltage needs to be, if you know what your input voltage needs to be, even if it's just one metric, what your power requirement is, you can start checking boxes, and it'll start filtering out the power supplies that don't meet that application. In addition to that, if you hit the support section, all of our latest catalogs are in the catalogs and brochures link, and then there's a contacts list too. It's cool for us as well. So when you do get down to that 3-phase 40-amp power supply and you know it's for motor, but you don't know which exactly one to talk to, we give you a way to call out, reach out, and get us involved to help you find the right one, the right power supply for the right application.
Any tips or tricks to finding the right power supply? I think we were talking the other day, you mentioned, if someone's looking for a 24-volt power supply, they probably should actually check, I think you said 24 to 28. Yeah. That's like the main bread and butter of the 24 volts. You know, things like that to not, I guess if you're using that parameter search, not over-filter yourself.
Exactly.
Type of thing.
Yep. Grab the 24 to 28 so you get that voltage range.
Yeah.
Yep. There's a pot switch on the front of the power supplies that allow you to dial up the voltage if you need a further run.
Sure. That makes sense, especially for further runs. Anything you can think of with the power supply technology or, trends you're seeing maybe in the next few years, people might be biting on, or maybe sneak peek on what Pulse might be developing, anything like that you maybe control cabinets starting to shrink because your power supplies are coming out. Any neat information or things you want to share on that?
Yeah, I think cabinets are going to continue to get smaller as manufacturers are trying to maximize the amount of manufacturing space that they have on their floor. And part of control cabinets getting smaller is getting rid of them altogether through IP67 drives, IP67 DC power, field I/O.
Yeah.
So I think it's just all heading that direction. And then the connectivity piece, right? Being able to trend your AC input, which you can do with the power supply, or the DC output, configure it remotely. I think more and more of that is where the industry's heading.
Yeah, I mean, we see it ourselves too. Myself and our applications group and our salesmen definitely see it all the time. Is I want that, but I also want to monitor it, or I want to be able to, get a text message when something is spiking, or things like that. Like everyone wants more data, and they want it easy access. And they don't want a specialist to have to go in and open the panel or hazmat suit type of thing, just for basics, So like I said, the more people are taking on the panel or the more they're monitoring things over iLink, et cetera, is definitely seems like the way everything's going.
Yeah.
I guess, I mean, really, I feel like we've covered really a lot on this and some good topics here. Probably, I think you're pretty close to wrapping ourselves up here. Is there anything else you can think about that you wanna share while I got you here on Pulse in general, or something maybe we skipped?
We're now stocking a 4-channel electronic circuit breaker that has the functionality that we talked about with the 8-channel.
So it's a minier version of this? Or?
That's what the M stands for. So it's PISA-M, PISA Mini. It's the width of a deck of cards on the DIN rail.
Oh.
It's pretty incredible what it can do. Still fully configurable via the faceplate with the buttons on the faceplate. You also get the same 4 separate monitoring methods and remote on and remote off.
What was the current output on that, or highest option on it?
So you get a 20 amp input,
20 amp.
and you can go up to 8 amps on each output.
Okay, that's impressive for how small that is.
I'm excited for it.
That thing's only like an inch or so wide. That's pretty impressive.
22.5 millimeters, yeah.
Yeah. Wow. So that's coming soon. Like it's not.
We have we're stocking right now.
Awesome.
As of the end of July 2025.
Wow. There you go. I'd assume that's going to be something, local reps and our salesperson will have access to demos, so if people want to see that in person or whatnot, we'll be able to get some, show it off to people, just like we have, the ones here currently.
Absolutely.
That's pretty cool. You mentioned, obviously, stocking and stuff, though, too. Barnum stocks a lot of Pulse.
Yep.
We stock a lot here. I assume you guys have a lot of stock of your own. So a majority of the catalog, I would assume, is pretty darn short lead time or immediately available. There's probably only some unique things or maybe extreme quantities of things that have a build time associated with it.
Yeah, it's very rare that we don't have inventory on anything. Again, being a 100% DC power solution company, we don't have all the different SKUs that other manufacturers would have to carry, having, not just DC power sources. So, yeah, 3 to 3 months is typical. 3 months worth of inventory on hand at any given point in time is pretty common for us. It's very rare that we would get caught without having inventory on hand.
That's nice. And I know, like, for people who've worked with Barnum in the past, if our suppliers ever forecast that there's going to be an issue, Barnum really takes it on themselves to stock it, forecast that ahead of time, make sure people are covered, just because, that's what Barnum likes to do. And on every single podcast, I find a way to say there's value added to that. The big thing what Barnum does is value added. Seems like that's one of the big main things Pulse likes to do is bring value added as well. It's not just a power supply. What else can we do for you? Well, it's a whole solution now in a box. It's not just power supply. So again, the value added is the core principles of Barnum and our partners. Well, overall, I think we had a pretty good power supply discussion here.
It's amazing we can go into a power supply conversation.
Right? I see that all the time. We get in some of these products, I'm just like, I don't know if we can talk that long about it, but once we get into it, I mean, it's there. It's interesting. There's a lot to it. And hopefully people listening or watching got a little out of this, maybe learned that there's more to it than like I thought, and why Pulse, even if you see it as a premium product and you don't need that, now you see why actually you might need that or want that, and give it a try on the next project.
Yeah, thank you so much for having me.
Thank you for coming on. I appreciate it, man.
Hopefully we get to do it again soon.
Yes. When something new and awesome comes out, let me know. We'll sit back down again. We'll showcase it. But overall, this is a pretty good one. And again, like I always say, if anybody ever has any questions, wants any information on these or demos, there's a local HH Barnum representative out there for you. Give us a call or find your local Pulse representative, and we will make sure to get you the info on these, get you demos, get you quotes, all that good stuff. Ryan, thanks again.
My pleasure. Thank you.
And that's another episode of Automation Nation Inside Barnum, and we'll catch you guys next time. Thank you.